Hello friends, a warm welcome to all of you on my channel. In functional analysis, I am going to prove a theorem which is very important. So please watch it till the end, and whatever I am trying to explain you, please watch it carefully, okay? So the statement of the theorem is, let n be a finite dimensional non-linear space, right? You have a finite dimension non-linear space and M, which is a subset of n. So M is compact, and the condition is M is compact when M is compact if and only if M is closed and bounded. So I will take this condition, how to prove it, okay? If and only if M is closed and bounded, these two conditions are exist, then M is compact, we can say, right? So how to show it that M is compact, right? So first I will write, I just want to prove it that M is closed, okay? So first I am going to prove it M is closed and M is bounded. So then I can say this problem, right? Then I can say that M is compact, right? So first and foremost I want to show that if M is closed, right? So I am going to prove it M is closed. So the first condition that I need to prove it. So to show that M is compact, closed, so I consider, suppose M is compact, I am considering that M is compact first, okay? So M is compact, I am considering. Then I want to show the claim, as my claim is M is closed, right? So I want to claim M is closed. So how I show it? So I am taking here X be a limit point of M. I am taking either M is a limit M in M set. So I am taking here X point, which is a limit point of M. So there exists, right? Of course, if I am taking is a limit point of M, so there exists a sequence, of course, then sequence will converge to this point, right? So there exists a sequence XM. XM is the general sequence that I am taking in M, okay? So such that XM will converge to X. It means I am taking XM, which is converged to X, means X is the limit point of the sequence, right? So there exists, this implies, what? This implies that there exists also subsequence XMK. If XM is a sequence which is converged to X, so there exists also subsequence XMK in M such that XMK also converges to X. And we all know what we know that X belongs to the M. Also we know that X belongs to M. So and we also know that since M is compact, right? So we can say that M is closed, right? If XM is a sequence which is converged to X and there is a subsequence also converged to X, and since M is closed, so M is compact also, so M is closed, right? This implies M is closed. So this is the first condition that you can show M is closed. And the second condition, to show that bounded. So here I want to show that this is bounded. So how I show that M is bounded? So to show that M is bounded, I want to prove it by contradiction, okay? So I want to just prove it. So I am by contradiction. So I am taking here M is not bounded, right? So what I am taking? I am taking not bounded means unbounded. So if I am taking M is unbounded, means that for every sequence XM that I am taking the sequence with general XM in M, so such that distance of X comma M is equal to the nothing but norm of XM minus XN, which is greater than N. Why I am taking greater than N? I am taking the negation of bounded sequences. So I am taking here, if I am taking this is bounded, so I can say that norm of XM minus XN is less than N, which is less than N, right? So it is bounded from N. But I am taking the negation, which I am taking N bounded sequence. So that's why I am write down here norm of XM minus X is greater than N. Then what? Then the condition is, then it has a subsequence also XMK, which is also equal to the norm of distance of XMK in the discrete metric. You can see the metric space. Distance of XMK comma X is equal to the nothing but norm of XMK minus X is greater than N also, okay? So what I'm saying there, where I'm saying that these are conditions, the sequences and their subsequences is also unbounded, right? So if subsequences is unbounded, means XMK, whichever my sequence is not convergent, right? If my sequence is not convergent, then what? Then this sequence is not convergent in M, which is contradiction, because I am taking that the sequence is bounded. So it will converge, but the sequence is not convergent here. So if sequence is not convergent, means this is a contradiction, means M is what? M is compact, means this is closed, M is closed. And also I have proved that M is closed, and this is M, here M, I proved that M is bounded. So if it is closed and bounded, then we can say that M is bounded here. And compact, for compact, since M is compact, I am taking this as a consideration. So now I need to prove it. See, if I now here I need to prove it. If this is closed and bounded, so I need to prove it M is compact now. Okay, so I am taking this conversely. Okay, so if I am taking let, I am considering what I am considering is let M is closed and bounded. Now I am going to claim that M is compact. I want to show M is compact, right? So how to show it M is compact? So like as earlier I told you that sequence is what? Sequence is finite dimensional. So if my sequence is finite dimensional, so dimension n is equal to, I am considering in small n. See, M is small n because this is the finite dimension. It has some dimension. Okay, so dimension and has some dimension, the finite dimension, and it has some also basis. So I am taking here basis of n is e1, e2, and so on en. I am taking as a basis of this n. Okay, so let xm be a sequence of n. I am taking here also sequence xm. So xm is a sequence of n. So what? So xm is a sequence of n, and we know that m is a subset of n also. So it is a sequence of n as well. So there exists a scalar. Some scalars still will exist. Like scalars are alpha 1 m, alpha 2 m. I am taking it the sequence type scalar. So is that why I am taking here this m. This is the every particular f for m के लिए. So alpha m, alpha 2 m, and so on, alpha n m. So we can write this is equal to the linear combinations of that. So alpha m em e1 plus alpha 2 m e2 plus and so on plus m alpha n m en, right? So there is a lemma that I want to show you here, or I want to describe it also. So now m is bounded. Okay, so if अब हमारे पास m है bounded, right? So we have already condition is that m is bounded, right? So norm of xm is here less than k also, because bounded, m is bounded. So we can say that norm of xm is less than k particular. So such that norm of xm is what? Norm of xm is equals to, we can write by the lemma. I have a lemma. What is the lemma? Lemma says that if you have alpha 1, alpha 2, alpha 3, alpha and some scalars, and you have some sequences, so what you can, and you have some basis also finite dimensional, so you can write that in norm of alpha m, alpha 1 m e1 plus norm of alpha plus alpha 2 m e2 plus and so on plus alpha m n m en, and this particular term is greater or equal c times, c is what? C is the non-negative number, so c is the non-negative term, so it is greater than 0. So c times summation of what? Summation of mod of alpha I m. So this term will greater or equal from this term. So I am taking here this term which is less than or equal. If I am taking this term, so this term is less than or equal 1 upon c times norm of xm. Okay, so norm of xm is what? Less than, it is k by c, because this says that this is bounded sequence by k, so k by c term. So I can say that is summation I is equal to 1 to n alpha I m is less than or equal what? K by c, right? From this condition now I can say alpha I m is also less than k by c, right? For all m. Now the sequence alpha I m be a sequence of scalars, right? So which is bounded. Then by Bolzano-Weierstrass theorem I want to prove it. Bolzano-Weierstrass theorem, that is sequence is convergent, then it has subsequences. Okay, so it has some sequence, convergent subsequence, like sequence what? Convergent subsequence is xim, which is convergent to alpha 1, alpha I for all I is running from 1 to n also. So I hope you understand what the Bolzano-Weierstrass condition is. If it is if you have a convergence sequence which is convergent to any point, and then it has also convergent subsequence, right? I know you all know that. So xim is convergent to alpha I for all I equal to 1 to n. So I am now defining a subsequence for xm, right? So of xm ki subsequences we are going to define it. So what is the subsequences? Subsequences like I am defining y1m time, y2m times, ynm times. I am taking the first, I am taking ym, which is gamma I am taking here. So in LL I am gamma 1m e1 plus only the first one is change. Okay, another one is remaining, the all of them is same. So alpha 2m e2 plus and so on plus alpha n em en. Okay, and then next is y2. I am taking the second term. So second term means the only two will change, the other rest of them are same. So gamma 1m e1 plus gamma 2m e2 plus and so on, all the terms are same, so alpha n em en, okay, and then so on in this type kind that, okay. So now yn m is what? Yn m is the last term of the sequences, so alpha gamma 1 m e1 plus gamma 2 m e2 and plus and so on gamma n I think होगा यहाँ पे, so gamma n m em, okay. So yeah, so now what I see, no gamma n m mn, okay, I'm taking it m, so I think this alpha is correct, okay. So yeah, so alpha 1 en plus alpha 2 e2 plus and so on alpha n en, what is this? This is the x, right? So now we have find this x, and now what we can do, this is the conversion of our sequence state with sequence conversion at this point. So we can say that ynm our sequence, that sequence is our ynm the sequence. So this sequence is converged to x, and x belongs to m, right? And m is also closed and bounded, so it is, and it is convergent, our subsequence is also converged to x point. So it means that what? It means m is compact, right? So this implies m is compact. It's a very simple approach to apply this sequence is if you have a finite dimension vector space and you have some bases, so there exists some sequence, you also some sequence, so this sequence where there exists a scalar, so I use the lemma. So if m is bounded, so this is bounded by k, I'm taking as k point, is bounded from k, so such that norm of xm is equal to this term. You can say write the simple addition of the scalars, multiplication scalars and vectors. So this is greater or equal than c times, and c is greater than 0 point, c is a non-negative number, okay. So c is the greater than 0, and then you can say that summation of this term is less than or equal to some k times c, okay, k by c. So this sequence is sequence of scalars alpha m, which is bounded, and then by Bolzano-Which term it has subsequence. Subsequence will also converge to x. So this sequence we can say that this is m is compact, right? I hope you understand. If you any query regarding this, you can please comment me, feel free to comment me, and I will definitely try to reply it. And yeah, new on my channel, so please subscribe to my channel, also press the bell icon so you can get all the notifications from my channel. Thanks for viewers.